All right, ladies and gentlemen, Fall 19 Test 3 roadmap time. Here's the roadmap. A comment about your test compared to Fall 19 Test 3. I am pretty sure they had a full 3 hours on their test. So when you're studying from Fall 19 Test 3, just shrink every section. Multiple choice will not be that amount of multiple choice. In fact, I'll tell you right now, it's going to be 12 questions. That's the only part I've made. Okay.
How many is it? What point?
36.
It was 25?
Oh, the exam's 180. So I knocked off 45 points from the original assessment, I think. So yeah. The only section that doesn't change point count is nomenclature, which is always 20. But it's shorter than the one there. Sorry, we had a question.
Which of the multiple choices did you take off?
I have she asked which of the multiple choices did I take off? Well, I'm almost done. I can tell you which ones I kept.
Okay.
That scheme, that's the first, 12 questions on yours?
Yeah.
Will be a scheme, the first 9 questions on yours. And I will pick 3 of my favorites from the remaining multiple choice. I do not know which yet. Okay? Yeah, so the first 9 questions of the 12 on the multiple choice will be the scheme, which will be an alkyne, acetylene, and synthesis. And we're going to do this scheme here, which is part 2. It's a roadmap, and we got to remember all of our reactions. This is all chapter 6 here, and it's got a couple reactions where alcohols have replaced water, like we just did in our previous exciting video. Exciting because I almost fell down. And we're going to have a similar result here. And here, there's a O-methyl here instead of an OH. So you're going to have to tell me how it got there in this one. In this one, you're going to tell me what happens to this alcohol. So we're doing D2 and PT on this thing here. And I don't want to draw the skeleton 100 times, although you have to. I know life isn't fair when a teacher can copy paste and we can't. So I'm doing it down here because I've learned my lessons. I'm just going to copy this skeleton a bunch of times. And the only reaction that's not going to have that skeleton will be the ozone reaction, right? Copy, paste. No ozone. Paste. No ozone. I have had students confuse OSO4 with ozone in the past. Please don't be that student. My paste is hidden. That's for reagents. You don't put a product in there. There. Oh, 3 points. That's huge. That's going to put chlorine and OH on. This is going to put oxymercuration and demercuration. No, 0 points so far. Sorry about that. Yeah. And, oh, we didn't grab my methyl. Look at that stray methyl just hanging around. Should have copy paste, huh? Yeah. Come on, buddy. It won't move. There we go. What about this one? Oh, I didn't put it there. That's the ozone. O3. Okay. So what 2 new groups do you have when you put D, 2, and PT? I remember that's one of those syn additions.
Yeah,
2 Ds instead of H's, because I wanted you to be able to show me that you knew there's syn, and if it's H's, all you would have to do is leave the product as is. And you know, there's no stereochemistry information there that way. Because, you know, the product as is has an H here. It'll be cis to an H here. There's no H there. That'll be a D. Your executive decision. I'm going to just start over here.
Oh, does that matter?
Yeah, you go wedge, wedge, or, hey, what the heck? She brought it up. I'm going to do it. Dash, dash. There you go.
Professor, if we just put the
2 Ds, no wedge, no dash, you get 1 out of 2. Yeah. Stereochemistry is half the points there, and putting the right groups on is the other half. Next one, you got to draw the osmate ester. How do you know this was the one where you draw the osmate ester and then you don't draw the diol? How do you know you're not drawing the diol in this box? Because you're thinking diol when you see OSO4, right? She saw some information about diol later on. That's the step that breaks the intermediate, well, the OSO4 product down to make the diol. So you're going to give me chemicals to do that. And I need to see the osmate ester in here. So what do I put at the end of both those wedges? Because it's another syn addition. Oxygen, oxygen, thank you. And each of those is attached to the same osmium.
And then it has a double bond.
It's osmium and it has double bond to O twice after that. So think of it like sulfate. Osmate and sulfate are, what do you call it? Isoelectronic. Oh, I haven't used that word in a while, sulfate. Okay? They have the same Lewis structure. Sulfuric acid and osmic acid. And the chemical, you've got choice here. You can use the Henry Ford chemical, the tert butyl hydrogen peroxide, or the OWL chemical, sodium bisulfite. So we'll use the Henry Ford one, and I'll make a comment. Definitely know that's a peroxide when I draw it that way, right? In this box, you could have also written NaHSO3. That's correct.
You have to look at water.
Water's not necessary to show there. I will not take points off if you put water, but you don't have to show water there. And that gets you down to a diol, and your catalyst comes back if you're curious what happens to your osmium. OSO4 is produced. Okay, going across, I got to put the less electronegative mercury on the less substituted carbon and the more electronegative oxygen on the more substituted carbon. That's an oxymercuration reaction in a nutshell. So the mercury, which mercury is this one? And there's clues right here. Is it the mercury sulfate or the mercury acetate? Look at the product. It's the one with the two acetates. Two. Hg, step one. HgOAC twice. You're saying, where's the other acetate? Well, I don't always show side. In fact, I very rarely show side products. Yeah, CH3OH or HOAC, same thing. What he was saying was CH3 carbonyl OH or CH3CO2H. That is it. And that's not going to put the O on. That's going to put the mercury triangle. And what's got to attack the triangle in this example? Please don't say water. Water would put an OH over here. Yeah, the oxygen is the same. And what's with it? H is with it. That creates an oxonium. And what else is with it? CH3. Thank you. So that combination would give that product, I numbered it because overall it's a two-step process. Second step is demercuration. You know, when I've separated them here, you don't need the numbers. You don't have to have the 1 and the 2 there. But usually they're both listed over one arrow, 1 and 2, and then you just go the alcohol. And this one's not an alcohol, it's ether. And what part of the name do you think has that in it already? I mean, we haven't done that nomenclature, but doesn't it make sense that's the name? Methyl, but it's got an O. So ether nomenclature is going to be a breeze in chapter 11, right? Because that's an ether. That's just a preview. And on the same carbon, you see the methyl there? Yeah, so we got this part of the name covered. Cyclononane. Mercury's gone. There's no mercury in the name. What is the chemical that replaces mercury with a hydrogen? Thank you. NaBH4. And where there was a mercury is now a hydrogen. Now, this is the biggest points here because there's 3 things going on. 1, you got to show me a syn addition. 2, you got to put the B on the right carbon and the H on the other carbon. 3, you've got to acknowledge the fact that you know this thing reacts with 3 alkenes. Stoichiometry. 1 of these, 3 of these. You have to know that. In fact, if you tried 1 and 1, you know what you'd get? If you had 1 mole of each, you'd get 1/3 of a mole of this. 1/3 of a mole. Lousy yield. Because you didn't understand that the thing reacts 3 times. So if you did this, you're going to get 2 points. You like 2 points? Better than 0. 2 points for that. This one is the next one that reacts. It's more reactive. This boron right here, this boron is more reactive than the original. So reaction number 2 is second alkene with this. Not second alkene with this, no. So 3 times, what are you going to do to get your 3rd point? You're going to erase the 2 H's. They are syn addition, so they must both be wedges or both dashes. Yeah. And how are you going to show that 3 of those groups end up on the boron?
R2.
R2, you can write first, and you got to define R. Everything here up to but not including boron is in your circle. Up to but not including boron equals R, and you're done. You got your 3 points. Didn't work for those 3 points. In addition, wedge, 1 point. Mechanism. They both happen at the same time in the mechanism. The bond to H and the bond to B happen in the same step at the same time. Every time that happens is a syn addition. Similarly, both bonds to D happen at the same time.
Professor, and did not get the point where we like instead of like the BH2,
Yeah.
the H alone, we put the R2 on the,
You put R2 right there after the B,
yeah,
there's no problem with that ever.
but like why the R2 though?
Because there's 3 R groups on this B and they're identical. BH3 reacts 3 times with alkene. This is BR3, this molecule.
Yeah.
It is BR3. The whole molecule is BR3. Please don't tell me there's 2 R groups and then this thing I drew in blue. There are 3 identical R groups in this molecule. And then you're going to take that molecule and react it with some set of chemicals. And I don't see boron in this name anymore. So, and it's been replaced by this. OL is going to replace that. OH replaces B. And what do they can't replace B? Okay, that's good enough. OH minus is one very important chemical. And H2O2, equally important chemical. They both must be there. That's the oxidation step that we've memorized the mechanism of. Been doing it nonstop.
Can we write NaOH?
Yeah. Anytime you write a spectator, it's fine. Yeah. You ask, can you write NaOH? You can write KOH, NaOH, LiOH, barium hydroxide with 2 OHs. That's not bad. But you could. Okay, which of these chemicals gets the chlorine here and which gets the OH from water? O, 3.5. Cl, 3.0. More electronegative O, more substituted carbon. This is a triangle mechanism. So if you choose to draw the OH on a wedge, yeah, I call it anti-addition. Trans can get you in trouble. Hey, this product right here, it was syn addition, the product's trans. Because H has a lower priority than C, and H was one of the new groups. So that's why we avoid using the word trans and cis when describing mechanisms. Because, hey, if the H is a wedge, the methyl's a dash. This thing's trans. Don't use the word cis or trans when talking about the mechanism. It's a syn addition, puts the new groups both on wedges. Anti-addition puts the groups on opposite sides. OH here.
How do we know?
And what's on this? We haven't told me what's on this yet. Cl. And then I can answer her question. You got a question?
The answer.
I love it.
Choose any.
She answered it for her. Yeah, I like that. Then the mercury one. Hey, we had the mercury one. I think we're going to copy this product with two changes. Yes, sir. This one, there's a triangle intermediate. Backside attack of water on the triangle makes one of these a wedge, one a dash. And then, well, at the end, yeah. The backside attack on the more substituted carbon puts the O. This one, you make a triangle with mercury, and water opens it as well. It's going to look exactly like this, except there's no chlorine. What's the less electronegative atom in this one? HGOAC. So I'm going to write down the mercury. It's going to disappear. So please, if you're writing right now, do not copy the mercury. Do not copy the mercury. This is the result of step one only. A lot of students ignore the second step. I don't know why. Let's not do that.
Professor, where do you put the triangle from?
You never draw a triangle on this page. Never once draw a triangle on this page. Triangles are intermediate.
I know, but
This page is products only.
you want to like do the intermediate form.
Where you put a mercury triangle. I'm sure that mechanism is going to be done later today. Okay, now what does step two do to the mercury? It gets rid of it and puts what in its place in this example? The D. Get rid of the mercury. Put a D in its place. Yes, I want the stereochemistry. Wherever the mercury was is where the D goes. And here's the deal. I like it. I like it. We're doing an ozonolysis. I like to blow it up because there's a very easy way to do an ozonolysis. What's your, what? Okay, a little monster. Okay. So O3, followed by some chemicals. Oh man, I did this again. I really don't like asking it this way. I'm not happy about this box.
You said it's the voters.
Yeah, if it shows up on yours, this will be a bonus. I'm going to write that there. This may be the second time we're doing this video. I don't know. It's okay. I never say the things the same two times, I don't think. So what's your secret for ozonolysis?
Instead of the double bond.
Yeah.
Break up the double bond.
Yeah. Yeah,
But
you
this
get,
one has a knuckle, so it's a little tricky.
yeah, well, the result after ozonolysis is over is going to be this, but sadly, I've already drawn this for you. Oh, my arrow's in the way. I'm just trying to make it look very clear what happened, and I took my eraser, right? Look. Guys, that is this thing right here. CH3 carbonyl. CH3 carbonyl. CH2 7 times. 1, 2, 3, 4, 5, 6, 7. CH2 7 times. CHO, aldehyde. Yeah, that's that product. But what chemicals are going to take this thing? And this thing, I would take two answers, but in bonus, it's bonus. So I'd take either of these answers. Yeah. And you can do a syn ozonide right here. Or star. And star is here, star. You could give its later intermediate. These are isolatable intermediates, so you could argue they're not even intermediates.
Why is it not down there?
Why is what? Who, not where? Who?
You put out the O's on the side. That's not where the double bond is.
Uh-oh.
Yeah.
Oh. Interesting.
Professor, can we just?
You know, you get the same result from that molecule. It's a coincidence. Yeah, she correctly pointed out I didn't have the right molecule. That gives us opportunity for more practice. Yeah, I didn't start with the same alkene.
But Professor, if we just drew the second one over there, the co-separating double bond, is that enough?
No, because I already drew this product for you. You get nothing for it. Wasn't asking for it. This one gives this result. Same logic. This is the real one. But guys, can you verify it's really the same molecule? They're both 1-methylcyclononine. Yeah, just this numbering direction is the only difference. So can I just do that and save us a little time?
It's fine, as long as we're able to put it on the bottom and get the point.
Well, you know, there's no points down here. There's none. Nothing down here is worth points. Okay, what I'm trying to do, did I draw everything except for the double bond here? Good, I did. I would have accepted this one too. You like that one? And they're both from the wrong one. But once again, with just rotate it a little, it's the right one. It's a disaster. Skip the question. Don't even say it. Sometimes you just say, okay, that's going to take too much time for me to figure out. Time to move on. What is the chemical that breaks this thing down? And it looks so, ladies and gentlemen, big hint, it looks like 80% of this molecule. Yeah, without the O. There's the third O right there. That's from ozone, that third O. Copy CH3 taken twice with a sulfur and you're done. CH3, 2 times sulfur. Dimethyl sulfide, it's called. Yeah. For the bonus wedge here, if you give me this one, I won't even grade stereochemistry. How's that? Plus, I'm just going to tell you right now, how's your ozone question going to look? You can replay the answer to this on your video. I will give you O3. I will give you a blank for this molecule at step 2. So here on your test, it's going to appear like this. 1, 2, CH3, taken twice, S, and then the bonus is no longer, I'm going to erase all this very soon. The bonus is no longer a bonus. You're going to put this molecule in the box. Because yes, I am going to predict or test you if you can predict ozonolysis products, which I didn't test on this test, and I don't like it.
It's easier.
It is easier. Yes, the version you're going to get is easier than this. And you will not have to provide this because I provided it. No, I could leave that as a blank. That's it. That's how I'm doing it. Yeah, I just came up with it. That's a blank. 2's a blank. And I want the final product. That's this in the box. Okay?
You want that formula in the box?
Yes, that CH32S you still have to provide me. I am going to give you a big fat hint again that this is a product. Yes, that hint will still be there.
So Professor, which one do we have to put in the box?
The one in the box.
So this one, the one with the
This molecule is this molecule, which needs to go in this box.
Okay.
And we're erasing all the stuff that wasn't really asked for on this test. There. Okay. And we missed that one. Well, let me get it. Yeah, it did. All right. Exciting. Bromine and an alcohol. Well, we did chlorine and water. It's the same reaction. Copy everything up to the O. Copy everything up to the O. Don't use a chlorine. I do that all the time. You know that, right? I forget I changed halogens and I leave the old halogen there. Teacher's world. You're not going to have an OH. You're going to have the O. What's on the O this time?
OH.
No, that's if you use water. We did not use water. O iso something. Yeah, iso what? Isopropyl. Exactly. We'll put it in pink. There's your isopropyl in pink. Right there. I want to make sure it looks isopropylish. Nice. Okay. And what about HCl? That's our first chapter 6 reaction. Good times. Major, minor. Oh, yeah. Markovnikov first. Yeah. That's the Cl on the tertiary. It is HCl, yeah. And the Cl on the secondary. And did we get all the boxes? We got all the boxes. And our next request was for the same test, the next little roadmap, which has to do with alkynes. So we are out of here if this thing ever lets us.
Now the part two, right?
Yeah.